So yeah, my name's Eric. I'm best known as the founder of project called Degen. And I want to talk to you today about cross-chain data architectures. I was looking at this to Sergey's keynote yesterday, and one of the themes in that talk was around TCP and around connecting different blockchains together to expand, what's possible to expand and create more new markets. And I really like that, and I think this talk will kind of drill into that that topic a bit and talk about a few different things. So, first, a little context for those of you that don't know what Moonbeam is. So Moonbeam is a layer 1 smart contract platform, Degen compatible. It's deployed as a parachain on the Polkadot network. And really, the key thing we're focused on is interoperability use cases. So we've been working on cross-chain and interoperability use cases for some time now. That is basically use cases on Moonbeam using different kinds of general message passing providers, of which TCP is now obviously a new one. And also, it's part of Polkadot, and Polkadot itself is an interoperability network, right? So a network of chains that are designed to work with each other using a built-in messaging system called XCM. And so really it is through our work on Moonbeam and working with different development teams building cross-chain use cases on Moonbeam, that's where a lot of the examples that I'm going to use in this talk come from. And while there will be specific examples, really what I want to do is try to think a little bit about the themes that we're seeing, different kinds of themes that will be equally applicable in other environments as well on other chains. And so I'll start by just framing things up a bit in terms of kind of the mental model I use when I'm thinking about these different topics. So one mental model I have is around compute. And so I'll put into the history of technology. I've been around a while. So I was around the development of compute, the last 25, 30 years. And I see a lot of parallels, right? There's this old saying that history doesn't repeat, but it kind of rhymes. And so this is one of the ways I think about how Web3 and blockchain interoperability will evolve, is by looking to the past on what happened with compute over time. And so, I think about early days when there was very few computers. They had a lot of features to be able to share the resources, right? So I'm old enough for university, we're sharing a big server basically. That feels kind of like an Ethereum-like idea, right? You're kind of sharing resources in one computer. Then you move to a world where you can have your own computer. So that's either a PC or a dedicated server if you're hosting an application. That's kind of where we are now, right? There's kind of this ability for everyone to have their own blockchain. It's getting ever easier to create your own blockchains. But really, the key inflection point on the compute side is when networking came around, right? When you could network these different computers together, that was the big unlock. And my own idea here is that a similar unlock will happen as blockchains become interoperable with each other. So similar to what happened with compute. And so I'm always thinking about these historical analogies. So I'm trying to figure out what the next step is. So why don't we start just by reminding ourselves why cross-chain at all? So I'm a developer. Why is it that I would want to build something cross-chain? And again, just referring back to the keynote from yesterday, I really think the first of these points is the most important. It's about market size. So the TAM of your application, your protocol you're building, if you just focus on one blockchain, well, that TAM is limited, right? And I think for anyone who's trying to build a protocol or an application that's servicing a lot of users, you need to reach those users. You need to reach the users of demand where they exist. So I think Sergey made this point nicely in the context of these banks that created their own chains. They're expecting users to come, and they said, well, actually, we need to go find the users and create markets for these different assets or being issued or services that are being provided. So to get this increased market is really the key driver. But there are also other drivers. So, for example, increased efficiency, like the ability to leverage different specialty functions for different chains to create a more efficient setup than having, for example, separate deployments that are isolated on each chain you're trying to target. And this concept of UX as well. We'll go through some examples where the cross-chain technique allows you to create a better UX. And I think this is also another key driver for adoption using cross-chain. So just very quickly on tech stacks out there, when we started Project Moonbeam, there was really Polkadot and Cosmos, the two interoperable chain ecosystems. Obviously, the landscape's changed quite a bit. There's a lot of activity on L2s these days. Almost all the major L2 ecosystems have this vision of creating an interoperable set of rollups now. So I continue to see that the landscape will be this kind of fragmented landscape with different enclaves of interoperable chains, which then these enclaves need to talk to each other. So that's kind of what I see the next 2 to 3 years looking like, these different ecosystems evolving. And so I want to go through a few examples now and pull out some themes that I think are relevant by looking at these examples around cross-chain. So one category use case that is kind of the low-hanging fruit that you see right off the bat is around what I call like asset automation. So asset automation, in this case, one-click assets. I'll give a couple of examples from Moonbeam to help illustrate it, but this can happen in a lot of different environments. So the idea is, so let's take the example of osmosis. For those of you who don't know, osmosis is a chain in the Cosmos ecosystem. It's a centralized exchange. And one of the features they have is there's an ability for end users to deposit dot into osmosis with one click. As a user, you're presented with a unlock, you hook out address, and you can deposit dot. What's happening behind the scenes when that happens? There's actually quite a few number of steps that are happening. So the dot starts from the Polkadot relay chain. It's actually moved to Moonbeam via XCM, the native interop protocol within Polkadot. It then uses a GMP to transit into osmosis. And then there's an LP or deposit action that happens on the osmosis side. So you have these 4 or 5 steps that are happening in the background, but the user, they don't see any of that, right? They just see this deposit and it happens. So I think this is an example of where cross-chain is being used to kind of hide complexity away from the user and automate a number of steps, including asset inputs, that create a better user experience. And so this is happening in a lot of different ways across a lot of different environments. And this is an example that I think this is probably one of the first things to get adopted when it comes to cross-chain. The same scenario happened in reverse with something called Moonbeam routing liquidity. That's just in the reverse direction, where you might get a main that kind of leads, you can one-click deposit it to one of the other chains on Polkadot. Behind the scenes, it transits via GMP to Moonbeam, and then gets rerouted onwards via XCM to its final destination. So I think in this example, again, you see a combination of 2 different GMP providers, 2 different kind of cross-chain compatibility protocols that are being tied together to create like an overarching scenario or effect. That's also something that I think we'll see more of, especially as these enclaves of different chains continue to evolve. So this asset automation, this is one example. It has these themes built into it. But let's look at another example. So I'm taking an example here from the Moonbeam ecosystem of a DeFi protocol called Prime. It's called Prime Protocol. It implements one of the architectural patterns that we've seen a number of teams adopt. So something called a hub spoke architecture. So a hub spoke architecture, what that means is there's a hub contract on Moonbeam, and you have a number of other contracts on other chains. They're tied together via general message passing system like a CCIP. And the idea is that a user can take an action on Avalanche, so let's say deposit something there, a message is sent back to the hub reporting that action. And then you can go to mainnet, for example, and say, okay, now I want to borrow against that. It queries back to the hub and says, this user has this set of assets deposited across other chains. Let me let them borrow. So it's kind of a protocol that spans multiple chains simultaneously. But like it's also can blockchain agnostic in a way, right? The user can interact with it from any chain. So I see this as an example of efficiency. Right? This is strictly better than having separate lending markets on each chain. You have a single market that's spanning multiple chains. So I see that as both like a UX to it and an efficiency to it. And this pattern is something that we're seeing multiple teams adopt because they'll be able to compete against these folks that are taking this unnetworked approach. And one other interesting point here is that what roles Moonbeam play? The users don't even realize they're interacting with Moonbeam in this case. Loom is in this backend role where it's kind of coordinating things. It's like a backend cloud. And so GMP messages are being sent back to Ruby. It's occupying the blob space in Ruby, but it's not something to directly interact with. Just to take one more example in the gaming space. But here for gaming, there's a game called XL Racers, spaceships, pilots, different NFTs you can purchase in the race. So their concept is that they have racetracks in different chains. So you have a racetrack on Medium, you have one on Ethereum, and so on. You can move your ships to different chains. Where things get interesting is that the race results. The results can have impact in the GMP protocols, back in Medium. And then there's an integration with another chain called Zeitgeist that offers a prediction market. So there you can take out wagers on who wins a certain race, or who's going to win. And there'll be payouts based on the results. So, again, it's not just applied to other use cases, to other domains. People are figuring out how to use cross-chain to extend out and reach users where they are, where the demand is. So let's just talk for a minute about some other trends we're seeing. For folks that are adopting different cross-chain messaging protocols as a core part of the architecture, there are some patterns that we're seeing in how they're thinking about things. And so I think one problem is for a lot of these protocols, the question is, okay, this cross-chain messaging capability is now a critical part of my app. If it's not working for some reason, then I'm dead in the water. Take the example of Prime that I just gave, where they're running a VAR protocol. So if the messaging system is not functioning, then the end user funds are at risk. They basically, users could get liquidated or be unable to interact with the protocol. So one of the things that we've seen is that a lot of teams that have cross-chains a critical part of their architecture are looking for redundancy options, right? So instead of going just with one GMP provider, how can I hedge my bets? How can I kind of create a high availability or redundant system? Can I use 2, 3, more than one? That starts to get a little bit complicated a little bit, right? So if you're going to use 2 or 3 different messaging providers, then the questions come up around, okay, how do I set this up in a high availability way? How do I make sure that things don't happen more than once? If something gets stuck on one, how do I retry it automatically? So there's a whole set of scenarios around kind of maturing and kind of making for a high availability setup, where we're seeing multiple teams hit and try to engineer themselves. And so one of the areas that we've been doing some work is around this concept of having a router or firewall for cross-chain messaging. And so the idea is, again, back to this historical analogy, is something like, if the GMP providers or the cross-chain messaging providers are like the networking providers, right? They're like the AT&T, Verizon, Telefonica, they're the people providing the transport. The question is, how do you provide logic across multiple of those? So it's kind of analogous to, in the networking world, something like a Cisco, right? Someone makes a router where the GMPs plug into this other protocol, which would then be able to express different kinds of routing logic. And so this is something that, we're seeing multiple teams kind of recreate the wheel. We're seeing them engineers this functionality into their own contracts. You see that once, twice, 3, 4, 5 times, and you realize, okay, there's probably something, a protocol group here, so everyone's not recreating the same wheel over and over again. And so this is some area I'm quite interested in. One scenario for ultra high reliability you might do is say, end of end. So let's say you have 3 GMP providers. You say, you know what? If I send out all 3 and make sure that at least 2 of the 3 agree on the other side. So that way, if someone were to try to compromise the system, you actually have to compromise 2 independent GMPs or bridges to be able to compromise the architecture. So I think this is something that we're going to see much more of moving forward. And on the firewall side, it's the same idea but for protecting contracts. Right? So when you have messages sent to your contract, now it's kind of like when KC were first networked. You have a whole new class of threats you have to deal with, right? People might try to send a message, trick your contract into doing something. So how are you protecting it then? Right? Like, are there certain no good sources and deny everything else? These are the kinds of things that we're helping developers with on Moonbeam. So kind of trying to tie a bunch of these pieces together there. How complex is, right? So I think the discussion I see a lot of developers having is, okay, there's these different deployment options now. Do I deploy on a smart contract platform like, like Arbitrum or Optimism, or just choose whichever one? Do I have my own app chain or app specific rollup? And I think for me, the future is kind of not binary with that. That's like a false dichotomy. You're going to have a smart contract in these shared environments because you can do unique things there, right? You can synchronously interface with other protocols that are in, for example, EVM alongside them. But you may also want your own block space, right? Your own, well, let's say, that can provide horsepower for the workloads that you have. And so I don't see it as a binary or the other, but they'll be together, right? You'll have contracts that are networked together, along with perhaps chains that provide backend capacity. In fact, specialized chains. I think that when you think about backend services, having different kinds of specialized chains makes sense. For example, for storage. Right? Storage is not something you can do in an EVM. And then, on the kind of front end side, it's extending out to meet users where they are. Again, back to some of the points that were from the keynote yesterday. It's like you can't just sit tight. You want to extend out and meet users where they are, especially where the demand is to create markets for whatever that service is. And so the architecture starts to look kind of like an internet application architecture, right? You have different components, potentially different chains, they're being combined together to create an overall effect. And so I definitely am interested in this and see this as kind of the way that things are going to move, with more specialized chains connected together and meeting users at where they are. The architectures that are used to build applications are going to get increasingly complex, but also scalable and potentially with like better user experiences. So this is something that's incredibly interesting. And if I think about when I get back to the talk around this analogy with compute, if compute evolved from these standalone computers to these highly specialized infrastructures, right? Think about AWS, and you have a number of specialized services. Each one of those services is backed by many, many different servers. The developers kind of mixing and matching and picking the services they need to build their app. It's very, very scalable, very easy to use. That's the direction that I see Web3 going in. Right? For Web3, you have a single EVM deployment with contracts into EVM. And that'll move to this environment where there's multiple specialized chains that are being tied together and acting as one system versus n number of systems that are each independent and not talking to each other. And frankly, I think Chainlink is very well positioned for providing infrastructure for that kind of future. In providing order support and functions features are released, and of course, not least of which is CCIP, which I fully expect to become a dominant player in the cross-chain messaging space. So, yeah, thanks very much. If you may want
That was Derek Yu, the founder of Moonbeam, coming to you live as the keynote speak today on day 2 of SmartCon 2023 here in Barcelona. We will be bringing you content live throughout the day, and we hope that you had an amazing time listening to an amazing person talk about the future of blockchain communication using both CCIP and Moonbeam as the relayer. We will see you on the flip side, and we will see you later. Have a great day. Oh, you thought we were going to end that quickly, did you? No, we forgot. A closed mouth does not get fed, and you cannot feed a closed mouth, meaning if no one knows you're looking for opportunity, opportunity can never come knocking. And if opportunity does come knocking and no one answers, it's going to keep on walking. And with that, we leave with the greatest, worst knock-knock joke on the face of the planet, and that is knock knock.